Alright, so let's just do an example problem with forces on a spring. So let's just say we have some spring attached to the wall, and the spring's natural length is 15 centimeters, which is 0.15 meter. We're going to push on our spring, so when we're done pushing on our spring, our new spring's length is 10 centimeters, so we're compressing the spring this way. So we come along and we push on the spring, and the new length is 10 centimeters. And let's say we pushed with a force when we were pushing, and our force is 200 newtons that we push with onto the spring to compress it to this new length of 10 centimeters or 0.1 meter. What we want to know is if we wanted to compress the spring down to 3 centimeters, how hard do you have to push to make the spring 3 centimeters? So the idea is we have the spring, we want to know how hard we have to push, so the final length is 3 centimeters. How hard do we have to push? So to get this, what we remember is that force is equal to minus kx. And in order to know how hard to push at 3 centimeters, we need to find k, the spring constant. So we know that when we pushed with 200 newtons, that the change in the length went from 15 centimeters to 10. So that means x in this case, when we pushed it down to 10 centimeters, that means x was 0.05 meters because it changed 5 centimeters. And we used a force of 200 newtons to do that. Now in this case, the x is negative 0.05 because we compressed the spring. So when we look at this, we say, 200 is negative k times negative 0.05. And we can divide the 0.05 over, so we have the negatives cancel, so we have 200 divided by 0.05, which is the same as 20,000 over 5. 20,000 over 5 is 4,000 Newton meters, which would be our K value. Once you know the K is the same for the spring at all times. So now if we want to know what force is necessary to get to 3 centimeters, what do? Well, we say that force is equal to minus our K, which is 4,000. And what we want to know is the change in the length from 0.15 to 3 is negative 0.12. It's going to change by 12 centimeters. So what we see is our force, 480 newtons. And so if we apply a force of 480 newtons, our spring will be down to 3 centimeters in length from the original 15. So this is just a problem looking at calculating a K value and then using that K value to make a second calculation.